Okay, so today what we're going to do is we're going to continue talking about limits. Now, again, the main idea with limits is we're saying, like, we're looking what number that we're getting close to. We're not looking at the actual number, but we're saying, okay, what's the pattern? What's the trend, right? That was the whole idea with limits. So when we're doing limits today, we're going to talk about one-sided limits. Now, I know it looks a little grainy. Is it okay? Like, can you guys read the PowerPoint, or is it pretty bad? Because, like, I don't know why when I stream it, sometimes the quality goes down. I have to just keep resetting it till I find one that looks good. Is this alright, or is this pretty bad? Blurry. Okay, worse than last time. Worse than last time, or same as last time? Okay, don't worry. I'll zoom in on those over there. But like, if is it kind of same as last time? Is it like livable? Okay, so basically, when we're doing limits, today we're going to talk about one sided limits. Now, the main idea with one sided limits is we're saying, okay, instead of saying where is it going to on the left side and the right side, we're just saying, okay, coming from one side, what's the pattern going to on the right versus what's the pattern going to on the left. So if I'm looking at this over here, this is limit as x approaches 1 plus of 1 over x. Now, the way we read this is it says it's the limit as x approaches 1 from the right of, and then my function, which is 1 over x. But that's how we read it. We read it as the limit as x approaches 1 from the right. The plus just means from the right, and then obviously the minus over here means from the left. So again, I'll zoom in so that way you guys can see it. But that's kind of what it means. It just plus means right, minus means left. So if I was looking at this over here and I said, okay, what is the limit as x approaches 1 from the right of this function over here? If I were to look at this, all I'm doing is I'm saying if this is 0, obviously I'm not able to figure it out because there's no point at 0. X cannot be 0. But as I'm coming towards the right, I notice I'm getting more and more positive, which means that this is heading towards infinity. However, if I approach from the left, I'm getting more and more negative, which means it's going more and more towards negative infinity. So from the left and the right, they're approaching different sides. So if I asked you what's the limit as x approaches 0, the answer doesn't exist. The limit does not exist because they're approaching different things. One's going to positive infinity, one's going to negative infinity. So there's no pattern that you can say here. So your answers does not exist. But if I specifically ask you where is it approaching from the right, then you can say, yeah, for sure, it's going to be heading towards infinity. Or if I'm asking where is it approaching from the left, it's saying, okay, it's coming from negative infinity. So again, these directional limits, or these one-sided limits, they're just saying, where's my limit approaching? Where's my number? What's my pattern approaching? As I'm only looking at one side. This is especially helpful when we're doing like piecewise and stuff, and like the function breaks and there's like these jumps and stuff like that. So we can kind of say, all right, yeah, where's it kind of going? Okay, any question on one-sided limits? Pretty simple, right? Plus means read it from the right side. Negative means read it from the left side. Okay, now again, one thing that you do want to make sure, just to hammer this home, when you're looking at limits, you're not looking at the actual point. So make sure that when you're looking at limits, you're not actually looking to say, oh, where is it going to be at this point? You're looking at the pattern, and for the limit to exist, if there's nothing there, like if it doesn't say plus or minus, you're just saying, okay, does it work for both of them? Or does the limit exist in general? Okay, and again, for the limit to exist in general, it has to be the same on the left and on the right. Okay, doing good on limits. Just a quick yes type in chat, please. We doing good? Good. Okay. It's pretty easy, but like there's a lot of little things with it, so that's why I figured we just do a lot of practice on it. So for now, here's what I want you to do. Let's just do true or false really quickly. I'm gonna count down from 10, and then given this function over here, can you guys see it? Or actually, I'm gonna mute, or not mute, I'm gonna reduce my face so you guys can see it. I want you guys to decide, number one, is this true or false? limit as x approaches 2 of f of x does not exist. Is that true or false? Type it in 10 seconds. I'm going to count down. Please have it typed in before I hit 0. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, it looks like a bunch of false and some of us have trues. So let's kind of look at this really quickly. Does the limit exist? Or the limit does not exist. This is false. The limit does exist. The reason the limit exists is because as I'm heading towards 2 from the left, I'm heading towards 1. As I'm heading towards 2 from the right, I'm heading towards 1. So that means the limit as I'm approaching 2 is going to be 1. The limit equals 1, but f of 2 is not 1. Again, I don't care that it jumps over. All I'm saying is, hey, is there a pattern that tells me where the numbers are going to as I get closer and closer to 1? That's what the limit says. Okay? All right, let's try this next one. Limit as x approaches 2 of f of x equals 2. Okay? Limit as x approaches 2 of f of x equals 2. Whoops, I might have just spoiled this one. All right, what do we think? 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, yeah, easy enough. False, right? It's false because we said it's 1. It's equal to 1 because it's approaching 1. Okay. Next, limit as x approaches 1 of f of x does not exist. So again, the limit as x approaches 1 of f of x does not exist. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, the answer is true. Okay, question. What is the limit, just for funsies, what is the left-handed limit? Or what is the left-sided limit? What is the limit as I approach from the left of x as x approaches 1? So if I were to add a negative here, what would it be? Whoops, let me zoom out again so you guys can see. If I was at a negative over there, what would it be? Yeah, good. -2. It's -2 because as I'm looking from the left, it's heading towards -2. Again, when we're saying left-handed limit, we're just saying, okay, only from the left side. I don't care about the right side right now. We're just focusing on the left side. It does not exist if you look at the limit as a whole because they're going to 2 separate areas, but from the left and only from the left, we can say that pattern is starting to head towards -2. Looks like we're doing pretty good. Okay, so we had a question like this last time too. It said limit as x approaches n of f of x exists on every point on the interval -1 to 1. And again, it's an open interval because you can't take limits at end points because you need 2 sides. So in this case, does the limit exist on every point on the interval from -1 to 1? What do we think? 10 seconds. 10. 6, 5, 4, 3, 2, 1. Yeah, that's correct. False. False is right because there's that little hole in the middle, and if you're looking at that exact point, the points immediately to the left and right of it, the limits don't exist over there, so it breaks it. We're gonna talk about that more when we cover continuity, but for now, when you see these breaks, it's the limit does not exist. Excellent. All right, how we doing? Doing good? Any questions? Okay, so -1 comma 1 is not a coordinate, it's your interval. Do you guys know are you guys, on a scale of 0 to 10, how comfortable are you with interval notation? On a scale of 0 to 10, how comfortable are you with interval notation? Okay, just as a quick review, since most of us are in like the 7 to 9.999 range, these parentheses means I'm not including -1. If they were brackets, they would say you do include 1. The way that you can tell that this is a coordinate and not an interval is one very, very simple way. It says the word interval. It's all context. Unfortunately, that's why when you're learning coordinates and intervals, you don't learn interval notation in Algebra 1 for the most part, because it's easy to confuse with coordinates, but now just gotta watch out for context. So yeah, -1 comma 1 is not your point, it's your interval because it says every point on the interval. Okay, I think Kaiki had a question. Let me see real quick. What was the answer to number 1? Okay, the answer to number 1, the limit does not exist, that was false. The limit does exist and the limit was 1 because from the left side here and the right side here, they're both approaching the same point, the same y value. Okay. Any other questions? Okay, again, as always, if you have questions, shoot them up. If not, I'm just going to be moving on. All right, next. So here's what I want you to do. I'm going to, oh, good Lord, this is not pretty. But what I'm going to do is I'm going to screenshot this and I am going to post it in the class chat. What I want you to do is I want you to get in your groups. I'm going to give you 10 minutes to answer A through K as best as you can. And then I'm going to go through it. Choose someone to represent you, so you write it down. And the way I'm gonna do it is I'm gonna say the answer to A is, and just type it out. So it should be all true or false anyway. Okay, so that's what we're gonna do. So please break up into your groups. I'm gonna screenshot this and post it up. Give me like 30 seconds. Okay, let's go. Hopefully that's relatively decent quality. From the top. Let me reduce my face here. So again, going over the answers. Number 1 is true. Number 2 is true. Number 3 is false. Sorry, I'm saying numbers, but yeah. Number 4 is one from the left is true. D is true. E is true. F is true. G is true. H is true. I is false. J is false. And K is true. Oh, sorry. Yeah, B is true. Did I say false? My bad. For D, why is it true? When you approach okay, so remember, I'm not actually looking at x equals 1. I'm saying what happens as I approach it. So I'm gonna take my pen here and I'm just gonna slowly move it towards 1. As I get closer and closer to 1, what number am I getting closer and closer to? If I zoom in and you guys can see it a little more, I'm heading closer and closer to 2. Even though at 2 I'm not using it, that again just revisits our rule of never ever ever actually use the number. We're just looking at the pattern. Kind of like an approximation, but we're just following the pattern. Sometimes it works out to be exactly the same, but we're not actually looking at it. We're saying like, okay, based on the pattern, based on its neighbors, what should be true? Oh, sorry, B is false. Yeah, my bad. I must have misread it. My bad. Sorry. Yeah, it does not exist. Or limit does exist, so it's false that it does not exist. Sorry. English is not my strong suit. Double negatives, the worst. Okay. Any other questions? Okay, it doesn't look like it, so I'm gonna be moving on. Okay, I'm just gonna like touch on this really quickly. So basically, when we're doing this, uh, sometimes you're given actual equations and functions for your limits and stuff, and it makes life really really easy. So let's look at this really quickly. It says find limit as x approaches 2 from the right and limit as x approaches 2 from the left. When I'm looking at it as approaching from the right, we can look at it from the graph. Obviously it's going to be 2. When we look at it on the graph from the left, it's obviously going to be 1. So find limit as x approaches 2 from the right, it's going to be 2. Limit as x approaches 2 from the left is 1. And then, does the limit as x approaches 2 of f of x exist? The answer is no. Whoops, sorry, I should have had that there. It doesn't exist because they're going to two different numbers. Okay, questions? Easy enough, yeah? Now, the reason why I liked this problem was because it actually kind of highlighted something that some of you guys were asking. What happens if there's no big dot? What happens at limit as x approaches 4? Okay, try to figure that out as best as you can. You don't need to break up into groups, but just take like 30 seconds, 40 seconds. What do you think is going to happen the limit as x approaches 4? What is the limit as x approaches 4? Yeah, it makes sense that it's 3, right? Because like it's just right here and it's gonna just come from here, it's gonna come from here. Even though it's not highlighted, it's still an important dot because just like middle children, they're still important even if the parents don't recognize them, okay? Exactly, and you can eyeball it, but more importantly, like Rocky said, you can use the equation to kind of work this out and just like find out what it is exactly. Does that make sense? Okay, so just because it's not at these like endpoints and it's not highlighted doesn't mean it's not important. It just means that whoever drew the graph decided not to highlight it, and a lot of times that's because it's not an endpoint. Just because it's not an endpoint or like a place where the graph changes, that doesn't mean it's not important. Okay, we're doing okay. Kaiki, I knew you had a few questions about like it limits being approximations and stuff. I know I'm kind of jumping back and forth from saying, oh, see, it is there, but it's not. Like, as long as the left side and the right side both are approaching the same number, then it works out. If that number happens to be there, great. If it's not there, that's fine, as long as the left and right go there. So it is kind of an approximation. A lot of times it will turn out to be the actual number, but normally we say it's an approximation just because sometimes it's not going to work out. And I'm going to show you in about like 45 seconds when it won't work out and how you deal with that. So after this, we're going to be moving on to our next section. It's kind of like a lesson, but it's just building off of this. Any questions before we move on? Because we're moving away from graphing now and we're moving on to algebra, or more algebraic stuff. All right, good to go? All right, let's go. Oh, I almost forgot about this one. Lastly, there are these things called sinusoidals, and like these oscillating graphs like this. If you have an oscillating graph like this, now if you look at this, it says sine as 1 over x. Like this is just a super rare case, so I'm just going to show it to you. Sine of 1 over x, you know that what this means is x is going to get closer and closer to 0, and as x gets closer and closer to 0, my 1 over x is going to get crazy huge. So like 1 divided by 0.00000000000000001 is like a couple, like billion, or like however many zeros that I said. That's how many zeros you have. So the closer it gets to 0, the bigger your number actually gets. But the interesting thing about sine is if I have sine of like 87 billion, then all that does, as you guys all know because of your sine charts that you guys all memorized and your unit circles and stuff like that, all you're going to do is you're just going to keep going around in a circle over and over and over and over and over and over and over again, which means that your number is going to start off at 0, then it's going to go to 1, then it's going to go to 0, then -1, then 0, then 1, then -0, then -1, then 0, then 1, then 0, then -1, then 0, then 1. It's just going to go back and forth no matter how big it gets, and the bigger the number gets, the faster it's going to go up and down again, which is why this like oh my gosh, I can't, the period between it gets shorter and shorter, and it just gets really, really condensed, but it never actually settles on anything. It just bounces back and forth over and over and over and over again. So if I'm saying what's x going to be as it approaches, or what's the limit going to be as I approach from the left, obviously it's 0, but from the right I can't say it's anything because it's constantly bouncing back and forth between 1 and -1. It never settles in between. No matter how close I get to 0, it never settles and we say, okay, that's close enough. It's always bouncing back and forth. So when you have these waves like this, these oscillating sinusoidals especially, that's where you kind of say, hey, the limit on the right side does not exist. Even though it does, there are points there, because it never settles down, it does not exist. Does that kind of make sense? Again, this is a special case, so it's just one of those you gotta kind of memorize. Doing good. Okay. All right. Good enough for me. If you have questions, feel free to let me know. If not, I'll be moving on. Okay. Next, we're going to be talking about evaluating limits algebraically. There are 3 ways that we can evaluate limits. Number 1 is plug and chug. Number 2 is factor and reduce. And number 3 is rationalize. These are your 3 tools that you're going to be using quite often whenever you're evaluating limits. Very rarely you're going to do graph limits. Sometimes it happens, but most part it is going to be algebraic. So let's kind of look at each of the different methods. So number 1 is a plug and chug. This is super, super easy. It's just plug in your number, and if nothing blows up, then that's your value. It's kind of like the whole, hey, if it looks like it's working, then it works. Like that's basically what we did for this over here. We said, hey, I can just plug this in and I can figure out what that number is going to be. We're using the exact same concept here. So if I were to just take this and I was to plug it in, I'd say, okay, what's the limit as x approaches 3? Well, let's just plug in 3 and see if that works out. So we're going to get 3 times by 3 squared plus 4 over 3 plus 3. So that's going to be, what is that? Gosh, what is 9, 27, 31 over 6. Done. That's your answer. That's your limit, 31 over 6. You just plug in your number. If it doesn't break any of your rules of math, you'll be totally fine. Okay, next we have something like this. This is a little bit more fun, but again, it's the same concept. If I were to plug in 0 for this, all I would get is cosine inverse of 0 plus 1 over tan inverse of 0 plus 1. What is the cosine inverse of 0? Does everyone remember their bubble boy and bubble girl? Without typing it into. What is cosine inverse asking for? Is it asking you for an angle, or is it asking you for a number? It's asking you for an angle. So if you're saying 1, you're saying that your angle is 1. Is that what you're trying to tell me? What angle gives you a cosine value of 0? There we go. Yeah, exactly. Pi over 2. So this is going to be pi over 2 plus 1 over. Okay, now what tangent, what angle gives you a tangent value of 0? Pi over 4 is 1. Okay, 0, 2 pi. Okay, real quick, why is 2 pi not accepted? It's accepted, but it's not accepted. Why is it not accepted? Bubble Girl didn't get murdered? No, it's, yeah, right, exactly. It's Bubble Girl, though. So Bubble Girl is in quadrant 1 and 2. Her baby can, like, chill in quadrant 1 and 2, but her baby can't yeet herself out of its body and jump back in. It doesn't necessarily work like that. Very rarely do babies leave the body and come back in. So you can't go 2 pi. Technically it works, but conventionally we just say it works at 0. All right. So we have 0 plus 1, and then now we have pi over 2 plus 1 over 1. And then it's just pi over 2 plus 1. And then it's just going to be pi plus 2 over 2. That's your final answer. Again, nothing's broken. It's not a pretty answer, but whatever. We're not here for the pretty answers. If we wanted pretty, we would work with Bubble Girl. Okay, questions? Plug and chug, super easy. If you want to evaluate a limit, just throw in the numbers. Make sure you guys remember how to work with your sine, cosine, tangent. I did very specifically choose cosine inverse because when you guys see that, I know you guys are probably traumatized from reading the Bible and like looking at all of the double angle formulas and stuff like that, and your brain was like, oh my god, what is. But just remember, whenever you're doing inverses are saying what is the angle that gives me that number. Chuck it into a calculator if you need to. Okay, questions? For plug and chug, there would not be. Yes, there absolutely would be, but you would no longer be able to use plug and chug, right? That was the whole rule. It says you can't use it if it blows it up, and if you have a denominator of 0, then math no longer works, which means you blew up your formula, which means you have to try something else, which is where we're gonna get to next. Very good question though. So here's what we're gonna get through next. So now here's what you do when you do blow up your formula and you have to mess around with it a little bit. So for example, if I was to plug and chug here, it would break, because if you plug in your 3, you're gonna get 9 minus 3 minus 6 divided by 0, and then that just breaks. So because of that, we're not allowed to use plug and chug here. Instead, what we're gonna have to do is we're gonna have to try the factor slash simplify and reduce. Now the reason I said factor slash simplify is because this isn't always going to be a factoring rule. Sometimes you're going to be given fractions on fractions, and when you simplify it down, it cancels things out nicely. So sometimes it's a simplifying thing. Please don't use don't use factor and simplify interchangeably. They are two different ideas, so please make sure that you guys keep them separate. My illegal math smuggling ring is apparently getting busted. All right, let's go. So here's what we got. If in this case, all we're gonna do is we're gonna factor the top and see if we can cancel anything. So on top, we're gonna just factor this. As you guys are all amazing at factoring, I'm just gonna run through it really quick. X minus 3 plus 2 over x minus 3. Hey, look, there's an x minus 3 in the numerator and denominator. We can cancel this. Now, this is a very big cardinal sin to do when you're in Algebra 2. In pre-calculus and Algebra 2, this is a huge sin to do, to just cancel out to cancel out variables. Now, you all know why it's bad to cancel out variables, because if you cancel out variables, you lose possible zeros, right? Like if you were to cancel this out, you lose the fact that x minus 3 could give you possible 0. It also gets rid of the fact that you're dividing by 0. Like you lose information if you cancel this out. But when you're doing limits, it's okay, because you're not actually looking at the number, you're looking at the pattern. So you're saying, okay, let's ignore that for now, but let's do this. Now, the reason why I'm highlighting this is it's super, super common for kids to see things like this: x parentheses x squared plus 5x minus 7 over like x squared plus 3x, and to be like, wait, I can like cancel out an x over here and just get rid of my x's. But you cannot do that if you're not working with limits, so please don't just throw that rule out. You never want to reduce when there's variables, because you lose information. However, if you are doing limits, it's okay. This is the one time that it's okay. I do want to emphasize that. But again, now that we reduced it down, we have limit as x approaches 3 of x plus 2, and then we're going to have limit as x approaches 3. This just becomes 5. So again, we simplify it out to get rid of our dividing by 0, and then after that we just plug in chug, and then we see what we get, which is again kind of coming back to what Matthew's original question was. Any questions on this? This one just takes time to see. Like, you just got to see, oh, maybe I'll try factoring it to see if that works. But like 90% of the time it's going to work. 10% of the time it's not going to work, where it's just going to be you cannot factor, or you cannot take the limit of this. Later on, I think probably once towards the end of summer, I'm going to show you how to use another trick that you're going to learn later in calculus to do this. So I'm not going to say it's not possible, but I'm going to say with this method, if you cannot factor it and get rid of your denominator, or get rid of the thing that makes your denominator 0, then we're just going to say, okay, cannot do this one for now. Okay, any questions on this? Okay, again, just last thing, please make sure that whenever you plug it in and you get a 0 denominator, you always look for factoring. That's like a really good place to start. Okay, lastly is rationalizing. Now, by rationalizing, you multiply by the conjugate. And yeah, this is normally whenever you have a square root. Whenever you have a square root, this is like a big hint, like, hey, most likely we're gonna be multiplying by the conjugate here. So when we're doing this, if I see this, we're just rationalizing, which means I want to get rid of my square root. The thing that's breaking is if I plug my 9 in over here, it's going to give me 0. So all I'm going to do is I'm going to multiply the numerator and denominator by square root of x minus 5 minus 2 and x minus 5 minus 2. Whoops. Square root x minus 5. Okay. When I multiply the top and bottom by this, what I'm going to get is x minus 5 minus 4 over x minus 9 times by square root x minus 5 minus 2. Okay. All I'm doing here is I'm multiplying by the conjugate. I'm using my difference of squares identity, which is how I knew that this would become this squared minus this squared, which is how I got this over here. Then after that, I just multiplied by the denominator. I didn't FOIL it out because you'll see why in just a second. Probably you saw it already. If I simplify the top, I have x minus 9 over x minus 9 times by square root x minus 5 minus 2. Because of that, numerator, denominator, they both cancel out. Again, this only works when we're doing limits. If we're not doing limits, then it doesn't really work. Then after that, we have 1 over square root x minus 5 minus 2. And then we're just taking the limit as x approaches 9. So it's 1 over square root 9 minus 5 minus 2. And then we have 1 over square root of 4 minus 4. And then we have 1 over, 2 minus 2. And then that's still going to give me 1 over 0, which means it doesn't work, which is why we just say this does not exist. For now. Concept still holds though. Whenever you see square roots, that's one of the methods you try. Unfortunately, at the end, sometimes it just comes out that it doesn't work out. So those are your 3 basic methods. Any questions on this? Again, this is just the algebraic way of doing it. You can always graph it out. Like you can just like take any of these, plug it into a graphing like Desmos or something, and kind of look, and then there will be like a gigantic hole at like the place at like x equals 9, but you can kind of see where it's heading to and stuff like that. So at least you kind of have a general idea. Again, sometimes even after you try, it doesn't fully work out, so sometimes you might have to use layers, but this is the general concepts. These are your 3 tools that you're going to work with for now to just try to evaluate these limits. Number 1, you're going to use your you're just going to try plug and chug. Number 2, you're going to try factor / simplify. And then number 3, you're going to try rationalize. Okay, we're doing okay. Okay, so since it looks like we're doing all right, last thing that we're going to do is we're going to kind of look at this. This is a really common problem that they like to throw on like AP exams and stuff like that. It's honestly pretty easy, but it's just confusing in the way that it's read. So what I want you to do is I want you to go in your groups really, really quickly, and I want you to figure out what is the limit as x approaches 3 of f of g of x's over g of f of x's. Okay, I'm gonna again screenshot this and I'll throw it in the chat, and then you guys can get working on that. Okay.